Okay, excellent. Thank you, everyone. Good to be here. Thanks for opportunity to speak here. My topic is critical to performance metrics of functional materials for IME. So I'm going to try to cover some of the highlights and key points in these 5 minutes that I have here. For those that are not familiar with Sun Chemical, we are the largest ink and coating and pigment supplier. I work personally in the division for advanced materials. We offer materials for electronics. You can see different applications here on this slide, but I will be really focusing on our Suntronic materials for printed electronics and more specifically on in-mold electronics. So the topic is the requirements or requirements metrics, performance metrics for IME. So as you can imagine, in-mold electronics includes multiple process steps, and it comes from printing, label printing, which is typically screen printing. Then it goes to say SMT assembly. It goes to 3D forming, injection molding. So it's a quite interesting process. But then it's not only the materials need to meet not only performance related to process, such as printability, processability, stability on press, drying, and things like that, but also 3D forming, which is really, you're stretching a conductor, you're making the cross section smaller, you're thinning the conductor, you're narrowing the conductor. So we really need to make sure that there's no cracking, no outgassing, no shorting between, thinning down the dielectrics between crossovers and things like that. And of course, injection molding process involves high temperature and high pressure. So the inks need to withstand the pressure and temperature of the molten resin coming into the tool. In terms of application-related requirements, materials need to meet the same things that traditional printed electronics requirements, printed electronic materials need to do, right? So electrical resistance, good insulation, low variance in performance, sheet to sheet during printing, all of that, low defects, and of course, end-use reliability. So when it comes to automotive applications, you can imagine a full list of reliability testing that these parts need to go to. Now, in terms of Sun Chemical, so we are, as I said, we are the largest ink and coating and pigment manufacturer, and we offer basically from graphic inks all the way through functional inks, solutions for in-mold electronics. So in terms of decoration and also some auxiliary products such as adhesion promoters, barrier layers, things like that are needed for the individual layers of the IME or decorated IME appliques or labels. We offer our Sun High-Tech Decomold in-mold decoration inks. We have the DMS, which is the solvent-based graphic ink series. We have DMT. This is a 2-pack solvent-based graphic inks, and then the DMU series, which is the UV curable in-mold decoration inks. Now we have range of colors, as you can imagine. You can also see on the pictures, and custom matches as well. And we now also offer a non-conductive decorative dense black, which is extremely important for the capacitive switches or any circuitry that that needs to be on the label, especially on the same label than the electronics. From the functional inks, we offer conductive inks, silver conductive inks that are used for interconnects, electrodes, antenna, heating elements. Carbon conductive inks, either interconnects or resistors. Our carbon can be also formable. They also carbon serves as a protective layer for connector pads. The dielectric inks certainly serve as crossover insulation, protective overcoats, and passivation for the tails that are coming out of the plastic parts. Now, we do have, again, full range of products for either single or multi-layer circuits for either one film or a 2-film molding process. We have had our solvent-based range for a while, and now we are actually introducing some newest technologies from Sun Chemical. We have a UV-based functional inks, mainly silver, and I'll have a little bit on those in next slides. So here, one of the key metrics, certainly for conductivity, is or conductivity and formability. So we have a range of silvers that have different level of conductivity and formability, and therefore they will be applicable to different end uses, such as, high conductivity is required for interconnects, antennas, heaters, whereas the lower conductivity, or less than 30, less than 25 milliohm square mil, and forming is required for things like capacitive switches and interconnects, lower power application. A snapshot of some of the forming tools here, and I know I'm in my 5 minutes here, but I'll cover it in maybe 30 seconds here. We have a very high formability from the newest UV curable IME silver. So you can touch base with me and I'll give you a little bit more information on that. We have fine line printable IME silvers now. They're highly formable as well. So as you can imagine, the finer lines you print, you can do either higher density interconnects or transparent electrodes, heaters, transparent antenna. You can combine fine line mesh with another transparent conductor like the PDOT or CNT inks for highly conductive transparent features. So you can see example of some of the inks that we printed that are suitable for IME, down to around the 20-25 micron level. And last but not least, our high reliability dielectric. You can see our newest generation is highly stable in the 10 to the 12 ohm resistance in the crossover. So you can imagine fairly thin layer of crossover between the layers of the silvers with 20 volt bias in 85 environmental chamber. So highly stable, highly reliable dielectrics as well. So that's it from my side. Some examples of the projects, my contact. So please let me know if you have any questions or you want to discuss further.